Now let's talk about the CAPM and the index model. So when you predict the beta, now the beta is estimated beta, which is the beta that is from the historical data. But real beta, like when you predict the beta, it's basically predict the future beta, and there's a phenomena called the mean reversion. Means that the beta move toward mean over time. It's the average over time actually. So it's converged to the average. Usually the market beta equals to 1. So even though we have like 1.20 beta, it may be moved toward this 1 as time passes. So we adjust the estimate from this historical data to convert the regression toward 1, which means that you basically estimate the kinds of probability of the mean reversion and adjust it. We are not going to really talk about detail about this one because we need to have the more statistical knowledge and the skills that to adjust it. But at least you have to know that the beta should be adjusted to predict the future beta. Now, what is the problem of CAPM? So CAPM has kinds of several problems. First problem is untestable theory. Okay, that's the big problem. So this is untestable theory. It's really hard to test because the beta is just estimation. We don't know really alpha and beta so we don't have that data, and we estimate the beta and alpha using historical data, assuming that the model is right. So it's untestable. That's the biggest problem. Although we have this problem is still useful predictor because it theoretically is right of expected returns, right? And these principles are still valid. Now investors should diversify so that we can eliminate this firm specific risk away. Systematic risk is the one that we have to consider. So this is represented by beta. So expected return is related with beta, right? Only systematic portion of the risk because we can diversify this terminal away, the firm specific away. Well-diversified risky portfolio can be suitable for a wide range of investors, which means that, so here, well-diversified risky portfolio, especially if the portfolio is market portfolio, this is the most well-diversified portfolio, then this is suitable for everybody, right? So at least if the portfolio is well-diversified, then it's good for many people. Now, one of the problems that we can think of for CAPM is now, why do we consider just one factor, which is the market risk premium factor, right? This is only factor that affect the risk premium of the individual asset, which may be float because there are other factors that may affect to the expected return. So there's called the multifactor models. Now there are more than one factors that may affect to the expected return of the individual security. That's what multifactor model means. So several systematic factors. Single factor model like CAPM model, the only factor, systematic factor, is the market risk premium. Now there may be other factors such as this is the treasury bond rate, bond market. So treasury bond rate may be affected to the returns, the risk premium of the individual asset. So you can build these two factors as models, and you have two separate beta in each factor, right? And we can estimate using multivariate regression. So suppose we can actually see this model. keep it. Yeah, you can see this model using different spreadsheet, right? So spreadsheet. Now let's see again the spreadsheet for this one. Multi-factor model spreadsheet. Oh yeah, just hold on please. And we can actually see the multi-factor model here too. So data now show that this data, again the data we use, right? Now we have the T-bond rate too. So instead of just the market risk premium, we can also use the T-bond risk premium too, using this one. So to do so, again, go to data, go to data analysis, do regression. Okay. Now Y range still same, the Google, right? So this is Y range. Right, and X range now is two variables. So you have market factor and the TBO, right? Two series. Up to here and okay. And you have multivariate model, right? Now this variable one is beta of risk premium, so as a market factor, stock market factor. The other is bond market factor, T-bond factor. And if you look at the p-value now, this is valid, right? The p-value is below 1%, but this is not valid actually, so we don't have evidence that this coefficient is not zero. So at least we know that, oh yeah, probability bond is not a factor that may determine the risk premium of the Google. Okay, so let's go back to the slide again. Now there is another famous multi-factor model which is called the Fama-French three-factor model. So Fama-French three-factor model is now Fama and French pick the three different systematic factors. The first factor, market risk premium. Second factor, HML, is high minus low, which means that now this is the factor that has the difference between the average of the high market to book value, so market to book value, the market value divided by book value, minus low market to book value. So market to book value may also determine the risk premium of the individual asset. The third factor is the size factor, small minus big. So this factor is now small firm tends to get higher returns than bigger firm. So this also can affect to the risk premium of the asset. So these three factors, now we use this factor and estimate the result using the data. Then we can also have different model too. So let's look at that models again using different data. So Fama-French data now. And open it. And now this Fama-French data, now data has market factor small, SMB small minus big, and HML the high minus low, and we have another factors here too. So again, the same regression model. We have risk premium of the Google here actually, right? So data analysis again, regression, and Y put is now right Google, and X is see these three. So three factors: market risk premium, HML, and SMB and OK, and regress, then this is the result. And we kind of see that like this model show that, well, that model has some problem, because now the model itself p-value is all have problem. So these coefficients may be not very reliable actually. So it's kind of the not reliable models for this model, but at least we know that there is alpha here. So p-value of alpha is below the 5% and 1.13, which means that now for Google there is some percentage of the return that may not be explained by this Fama-French model. You actually have the access return. So based on the CAPM, we don't see any access return for Google, but now based on this model, we see actually the access returns, which is represented by alpha, is the intercept of the regression. The p-value is below 5%. So you can use this model to find the factor of the D3. So kinds of regression you can find, and you can compare with the others. I believe there is an example in textbook too, so you can follow the examples and see do how to see if there's a difference of the coefficients for each model.